Hello everyone, Mr. Chu here. When I was in high school, I was taught a way to find the exact digits in a square root, and it is a lost art. I even had to explain how to do this to two of my best math professors at Indiana State University. So I'm going to share this with you so that we can have it documented. So sometimes a square root looks like a little check mark, looks like a division sign, and you can put a variable underneath it. Sometimes it doesn't go all the way over that number or variable, and this particular program here does it like that. Sometimes you're trying to find the square root of a number that ends up being a decimal, and that's an issue. If it doesn't end up being a decimal, it is a perfect square. So we're going to define what a square root actually is. The square root of a number is a number that you multiply by itself to equal the number under the radical sign. So let's look at a couple examples first off. So the square root of 4 would be 2 or negative 2. There are two roots. Why? Because 2 squared equals 4 and negative 2 squared equals 4. And 4 happens to be what's called a perfect square. The square root of 16. That's the way you would read that. And you could read it radical 16. That's another way that it can be read. See, the two roots are 4 and negative 4 because 4 squared equals 16 and negative 4 squared equals 16. The square root of 169 is 13 or negative 13 because 13 squared is 169 and negative 13 squared is 169. But what happens when you have a number like the square root of 12? So when you think in your mind, there's not two numbers multiplied by themselves that will give me 12. So I just want to mention one thing. There's something that's called the principal root, and in most math classes, you would talk about the principal root, especially if you're talking about length, because it can't be negative. So the positive root is usually the one people think of, but there usually are two roots. Most students grab a calculator and then will round it if it's a non-perfect square, and they are called irrational numbers because those decimals go on and on forever. But what if you don't have a calculator? So there's something that's called the square root algorithm. It looks a little bit like division, complicated, so it's better off that I show you an example while we do it. So we are going to be doing example 1 in this particular video, and then if you follow me, you can follow along and see example 2 that's a little bit harder. So if I want the square root of 12, I take and put a long square root sign, and I put a 12 inside it, and then I put a decimal point. Then you can see we've got double zeros with what I call a little caret in between them. Double zeros, caret, double zero, caret. Now, we just have to follow along. It is a pretty complicated process here. So, what you end up doing, you write the largest perfect square above the 12 that can be subtracted from the 12. So 2 squared is 4, 3 squared 9, 4 squared 16. So 3 is that biggest number. So I write a 3 right up above the 12. Then there'll be a decimal point here. And then I square it. So I square a 3, it becomes a 9. This is where it looks a little bit like the division algorithm. 12 minus 3 is not, or 12 minus 9 is 3. Then I bring down my double zeros, and you bring them both down. Here's where there's a little trick to this, and you've got to know how to do this. So now I take this number, 3, and I'm going to double it. All right? So I double the 3, and I write it in below the problem as 60 something. So It's going to be 3 doubled is 6. And I know you're saying, why is he saying 60? So it's going to be 6, and then this dash here is just the way we do it, okay? So then I say, how many 60-somethings can I subtract from 300? And then people will end up saying, well, that's 5. No, because whatever number you put up here, you have to put on this little line here. So it's going to be a 4 because the 4 has to be down here. Then I take this 64 and I multiply it by the 4 that I wrote up there. Ends up being 16, carry the 1, 256. So I take my 256 and I write it up here. Then I subtract it. Ends up being 44. Then I bring down my double zeros. Now's where the numbers are getting kind of big. And this is why people struggle with this, because the numbers are pretty big. Now I'm going to go up. Remember what we did? We're going to double the 34. So I double the 34, and that's going to be 68. And it's going to be 680 something. Okay? So you think how many 680 somethings will go into 4,400? So I know 6 would be a little over 3,600. 7 would be 4,200, and I have to carry the 5. So it's going to be a 6. I put the 6 down here, and I multiply by 6. 6 times 6 is 36. Carry the 3. 6 times 8 is 48, plus 3 is 51. Carry the 5. 6 times 6, 36, plus 5 is 41. And you can see you can subtract that. And then you'll carry down the 2 zeros, double this number, and do the same process. So I always take and show people that, yes, I do have a calculator that I keep here at my desk. We're going to take, and in the calculator, you could take and find out what the square root was, and it's 3.4641. So example 2 will be worked in part 2, just so that you can see another one. I'll work through it a little bit quicker. Follow me on TikTok, and you could see more of my math videos. Thank you, and there will be a link up to the part 2 at the end of this video. I appreciate it, and please follow me, and we'll do more math as I come up with other ideas to post. See you next time.